Hello, chemistry students, and welcome to a new chapter. This will all be about kind of writing formulas and different ions. So the first section in chapter 9 is labeled naming ions. So we'll go over a little bit about how to name ions in this first section of chapter 9. So a monatomic ion. Ionic compounds, if you remember, consist of a positive metal ion and a negative non-metal ion combined in proportion such that their charges add up to a net charge of 0. For example, sodium chloride. One is made up of one sodium ion, that's sodium with a positive charge, and one chloride ion with a negative charge. The most important step in learning the chemistry language is to be able to name and write the chemical formulas for all ionic compounds. So step 1 will be to learn about the ions that form the ionic compounds. Monatomic ions will consist of a single atom with a positive or negative charge resulting from the loss or gain of one or more valence electrons. Cations form when metallic elements tend to lose valence electrons. All group 1A ions have a 1+ charge, for example, because they have lost one valence electron. All group 2A ions have a positive 2 charge because they have lost 2 valence electrons. And all group 3A ions have a 3+ charge because they have lost 3 valence electrons. So the names of the cations of the group 1A, group 2A, and group 3A metals are the names of the metal followed by the word ion or cation. So for example, Na positive is sodium ion, Ca2+ is calcium ion, and Al3+ is aluminum ion. Anions are nonmetals that tend to gain electrons in order to form anions. So the charge of a non-metallic ion is negative. The charge of any ion of a group A nonmetal will be determined by how many electrons they need to gain to be a noble gas. So non-metal charges, all group 5A nonmetals have 5 valence electrons, and they need to gain 3 electrons to be a noble gas. So the charge on those would be 3-. All group 6A nonmetals have 6 valence electrons and will need to gain 2 electrons to be a noble gas. So the charge on those nonmetals will be 2-. And all 7A nonmetals have 7 valence electrons and will need to gain 1 electron to be a noble gas. So their charge would be 1-. Anion names start with the stem of the element name and end in IDE. So for example, nitrogen is nitride ion with a 3- charge. Oxygen is oxide ion with a 2- charge. Fluorine is the fluoride ion with the 1- charge. Metals that form more than one ion. So many of the transition metals, which are between groups 1B and 8B, form more than one cation with different ionic charges. Metals that form more than one ion, the charges of the cations of many transition metals ions must be determined from the number of electrons lost. So for example, iron can form either iron 2+ if it loses 2 electrons, or iron 3+ if it's lost 3 electrons. 2 methods are used to name ions that can have more than one common ionic charge. Writing the ion with the charge as a Roman numeral, and then using the Latin name and changing the ending of the element name. And we'll go over an example of that. When you write the name of the cation with a Roman numeral, you write the name of the ion and then the charge as a Roman numeral in parentheses. So for example, iron 2+ would be iron with the Roman numeral number 2 ion. Iron 3+ would be iron with the Roman numeral 3 ion. Lead 2+ would be writing out the word lead with the number 2 Roman numeral. And lead 4+ would be lead with the Roman numeral 4 ion. When using the Latin name, you write the root word with different suffixes at the end to represent the charges. So the suffix us, O-U-S, is used for the lower cation charge, and the suffix IC, ic, is used for the higher cation charge, and we'll go over examples of that. Examples, iron 2 plus would be ferrous, iron 3 plus would be ferric, lead 2 plus would be pumice, and lead 4 plus would be plumic. A few transition metals only have one ionic charge, and because of this, their ion names do not include the Roman numerals. Example, silver is just Ag plus, cadmium is Cd2 plus, zinc is Zn2 plus, and so forth. Polyatomic ion. So a polyatomic ion is composed of more than one atom, and a polyatomic ion will behave as a unit and will carry a charge. The sulfate anion, for example, consists of one sulfur atom and 4 oxygen atoms, and these 5 atoms together will comprise a single anion with an overall charge of 2 minus. So the formula for sulfate is SO4 2 minus. That's a polyatomic ion. These are other examples of polyatomic ions. We have ammonium, NH4 plus, nitrate is NO3 negative, sulfate is SO4 2 negative, and phosphate is PO4 3 negative. The names and formulas of some polyatomic ions are shown here. You can see their charge, their formula, and their actual name. And note that the names of most polyatomic ions end in -ite or -ate. Sometimes the same 2 or 3 elements will combine in different ratios to form different polyatomic ions, as you can see there between sulfite and sulfate. That's a good example. Note the number of oxygen atoms and the endings on each name, and pay attention to the patterns seen in the number of oxygens and the endings of the polyatomic ion names. So sulfite has 3 oxygens, nitrite has 2 oxygens, chlorite has 2 oxygens, and chlorate, you can see there as well, has 3 oxygens, nitrate has 3 oxygens, and sulfate has 4 oxygens. So you can kind of see the differences there. The charge is the same on each polyatomic ion in a pair for which there is both an -ite and an -ate ion. The ITE ending indicates 1 less oxygen atom than the ATE ending, as you saw before. However, the ending does not tell you the specific actual number of oxygen atoms in the ion, but in general, the ITE ending indicates 1 less oxygen atom. So for example, the nitrite ion has 2 oxygen atoms and the sulfate has 3 oxygen atoms. When the formula for a polyatomic ion begins with a hydrogen, you can think of the hydrogen as representing a hydrogen ion, H positive, combined with another polyatomic ion. So for example, HCO3 minus is a combination of H positive plus CO3 2 minus. So when you combine the H positive plus the 2 minus CO3, we get an overall charge of just 1 minus. Note that the charge on the new ion is the sum of the ionic charges of the 2 component ions. And that takes us through section 1. Thank you for listening, everybody. Take care.